Hello, so in today's video, we're going to ask the question, what is a function? So you would have seen the word function in maths, in GCSE maths, and now in A-level maths and school maths. You would have heard this word function, but what actually is a function? We need to know what a function really is. So just before we go into that, let's just look at some notation. So you would have seen this f of x notation, or maybe this g of x notation. It doesn't matter what letter you choose, but this is the notation you use to denote a function. Now, you may also see this other notation as well. So f colon, so f such that x is mapped to x. So this is just identical to this up there. This one here, g such that x is mapped to x squared plus 3x, is exactly the same as this here. And x is mapped to sine x for this function h is the same as h of x equals sine x. So you may see this notation as well, so just be aware of that. Okay, so a function then. A function or a one-dimensional real-to-real function, you don't need to really worry about the technical details here for A-level maths, but technically the functions we deal with are called one-to-one real-to-real functions. But a function is a mapping that takes real numbers as an input. So you're going to input numbers into the function, and you're going to get an output. You're going to output one real number. So for every input that you put into our function, you get out one real number. And the key thing is you get out one number. So when you put in a number, you get one number out. So you won't get 2, 3, 4 numbers. You get one number out. So for example, let f be a function such that f of x equals x plus 1, where x is a real number. Now, it's important actually with these functions, as we'll see in future videos, that you put this here, that you put the set of x values in which you define your function. And this is called your domain, or your domain of definition. It is crucial that when you define a function, or when you write a function, you state the set of x values where it's defined. So for example, this one here, f of x is x plus 1, where x is a real number. So this function works. You specify this function works for real numbers x. Okay, so let's look at this example. So let's pick any number, any real number x. So it could be 2, minus 10, 100, whatever you like. Then you're going to plug it into f. So you're going to plug the number into the function. You get f of 2, f of minus 10, and so on and so on. Now, you get one specific value, don't you? So you plug in 2 into f, you get 2 plus 1, you get 3. So 3 down here. If you plug in minus 10, plug in minus 10 there, minus 10 plus 1, you get minus 9 there. Okay, so basically, we plug in the number and we get one specific value out. So this is a function. So this is a function, because that's what functions are. That's what functions must do. Okay, so we know that. Now then, this diagram here is going to help us see what really goes on with this function. So when we plug in as an input the number minus 3, we're going to plug it into our function machine, this f of x equals x plus 1. And then as an output, what do we get? So minus 3 plus 1 gives us minus 2. So we get out minus 2. And then we can keep on going with the rest of these. Plug in minus 2, we will get out minus 1 this time. Plug in minus 1, we will get out positive, we'll get out 0, because minus 1 plus 1 is 0. Plug in 0, we get positive 1. Plug in 1, we get positive 2, and so on and so on. I think you see the picture. So what we get when we plug in a number into this function, so one number gives us one number out. So one unique number gives us one unique number. This is called a one-to-one function. So this is an example of a one-to-one mapping, or a one-to-one function. So yeah, so f of x equals x plus 1, where x is a real number, is an example of a one-to-one function, also called an injective function. You may see this term as well if you do higher level university maths, for example. So in other words, every output is obtained by one and only one unique input. So one unique input gives you one output. That's what a one-to-one function is. Now let's look at a diagram of examples of one-to-one functions. So again, one unique input on the x-axis gives us one unique output on the y-axis. So with this graph here, again, we plug in a number on the x-axis, we get an output. Plug in a number, get a number. Plug in a number, get a unique number. So every unique x value that we input in gives us a unique y value. This is called a one-to-one function. The same idea with this, giving us a one unique value. Same idea with this one here. Plug in the next number, get a unique y number. Plug in the next number, get a unique y number. So these functions are called one-to-one because we plug one number in, we get one output out. So how do you tell if a function is a one-to-one function? So you can do something called this horizontal line test. So what you can draw is you can draw in a flat horizontal line like that. Now, if there is one point of intersection and one point of intersection only with that flat line and your function, then it is a one-to-one function, because for every one in output, you get uniquely one, sorry, for every output you have, there's a unique input for that output. Now with this one here, the first one definitely is, because every horizontal line we draw, we get one point of intersection. Now with this one, this is not. We've got more than one point of intersection when we draw the horizontal line. This is not a one-to-one function. It's still a function, and we'll see in a minute, it's still a function. But this is not a one-to-one function. This is actually called a many-to-one, but we'll come on to that in a minute. Again, this one here, draw your flat horizontal line. At any point you like, you're always going to get one point of intersection. This is a one-to-one function. Unlike this last one here, this is not one-to-one. We get multiple intersection points with the horizontal line test. This is many-to-one, not one-to-one. Okay, so that's that. Now let's look at another example. So let's look at f of x equals x squared minus 1 with our domain x in the real numbers, so every x in the real numbers. So again, we can write it like this in this notation. So f maps x onto x squared minus 1. Okay, so again, we pick any number, 1, minus 1, so on and so on, whatever number you like. Plug it into your function, so f of minus 1, f of minus 2, whatever you like. Now notice you get one specific value out again, don't you? Plug in 1, 1 squared is 1, take away 1, 0. Minus 1 squared is 1, take away 1, 0. You get one specific number out. So again, this is a function, because we get one number out when we plug a number in. Now the thing with this one, when we do our function machine, if we plug in minus 2 into this, minus 2 squared take away 1 gives us 3. So we get 3, we go to this one here. Now let's plug in minus 1. Minus 1 squared is 1, take away 1 is 0. So when we go to the machine, we get that out. Now how about 0? 0 squared is 0, take away 1, minus 1. So we get, I'll do this in a different color. We get this one here. How about 1? So 1 squared take away 1 is 0. We get 0. Okay, so with this one, we've got multiple inputs. So this one and this one that give us the same output. And similarly with the number 2. So plug in number 2. 2 squared is 4. Take away 3. Sorry, take away 1 is 3. So we get two outputs giving us the same. So two inputs there and there giving us the same output. This is called a many-to-one. So multiple inputs are giving you the same output. We call it many-to-one. So in other words, there exists, so with this example, there exists outputs in which multiple inputs could give you this output. So for example, x equals minus 1 and x equals 1 give you the same output. So yeah, as we can see with this here, so two inputs, x minus 1 and x, give the same output 0 for this function here. And we can see it by a diagram there. So an input of minus 1 and an input of 1 give us the same output 0 there. So this is called a many-to-one function, because multiple or many x values that you input into our function f give us the same, can give us the same output. So what do many-to-one functions look like? I look something like these. So like, for example, this quadratic here. Again, this is many-to-one, because if you draw a horizontal line, we've actually got many points of intersection. So this time a many-to-one function is where you draw a horizontal line and we get at least one point of intersection. Same thing with this cubic kind of graph here. Again, draw a horizontal line. This is not one-to-one, because a horizontal line drawn in would give us only one point of intersection for a one-to-one mapping. It's many-to-one because many points, many x values give us the same y value there. For example, the 3x values here give us the same output, this output on the y-axis there. So that's why this one's many-to-one. And again, for any horizontal line you draw. And the same with this one. So yeah, we have like a sine kind of graph here, don't we? So this is kind of like a sine wave, or like a if you shifted it across maybe a cosine wave, like one of these trigonometric waves. And again, this is definitely a many to one function, because if you draw your horizontal line in, for multiple values of x, there, and so on, we get the same output. So for many x values on our x-axis, for many inputs, so again, this x-axis is kind of like our input axis, and this y-axis is like our output axis, we're getting multiple outputs. So, sorry, we're getting one output for many inputs. So these are all many to one functions. So again, what can many to one functions look like? Can't be anything like this, because again, when we draw a horizontal line in, we've only got one point of intersection. So this is a one to one. One input gives you one output. One output comes from one input. This one is definitely many to one, because one output can come from multiple inputs. So this is many to one. This one here, again, is a many to one, definitely many to one, because for one output, like this output here on the y-axis, you can have multiple inputs. So this is many to one. And then this one here is not a many to one. This is one to one, because for one output, for every output that we have one unique input. So this is a one to one function, one to one. Okay, great. So then the key summary for today then is that functions are either one to one or many to one. So they're one or the other. There are no other options. It's either a one to one function or a many to one function. They're one or the other. So that's the key point you need to understand. So if you input a number into a function, you must get one number out. So in the next video, we're going to look at mappings where you may get two outputs. So they're not functions. Functions give you one number out. So when you put a number in, you must get one number out, not two, three, four numbers, one number out. Functions must have a domain of definition as well. So for example, f of x equals x squared. Now you must specify this domain. You must say that x can be a real number, or you could say, for example, alternatively, you could say something like x is between 1 and 0. So that's another possible domain of definition. You've got to specify the set of x values for which this function exists, because in order for you to define a function, you need to specify which inputs you're allowed in order for the function to work. So the domain must be given, and the domain is the set of x values for which the function is defined, and you choose that, or the question will choose that for you. So yeah, that's just a key summary of functions. And in the next video, we'll look at non-examples of functions. So what wouldn't be a function? So we'll do that in the next video.